can't justify that.
I would never have got. I never would have known like where. And that's my main issue. I would never figure out
Where to put, okay. Y'all, I saw,
23. Forget 23. Yeah.
yeah, I forgot to go. 21, I disagree with their answer, and I go with my answer.
Alright, so let's
All right, I saw something like, yeah. Huh? Yeah. I saw, oh, yeah, I have 2.2. I saw something on the little calculus site that I'm on, and they said whenever you start this, I wish I had done it. Give everybody high C's, so you remember to put the plus C at the end. And then every time your students don't, you make a slurping noise to remind them of the high C. That is so something I would do, though. Okay. I can still do it. But I did end up bringing them, didn't I? Just late? Yeah. All right. What'd you let your U be? Oh. I would do 1 minus x. All right, so what is du? So I have u squared, I have dx, I need a negative here, right? And to counter that, I'd also do a negative on the outside. Y'all okay there? So I'd end up with negative u to the negative 2 du.
always forget exactly.
Okay, I got here.
Okay, I'm going to add 1. All right, I'm going to keep that negative. I'm going to add 1, which would make it negative 1, right? So then I've got a negative 1 u to the negative 1 plus c. And I had let my u be 1 minus x. So 1 over 1 minus x, or 1 minus x to the negative 1 plus c. It is. Pull it out if that confuses you. Pull it over to the side. Like, yeah, just make it like this, dx, or even do it 1 minus x negative 2. Which other one did y'all say? 23. Ew, gross. Oh, but they tell you the u. Cosine t over 2 squared. I bet that's going to be my u. Sine t over 2. So if u is 1 minus cosine t over 2, what is du? Sine, because, yep, sine t over 2, but I got to chain it, right? Before even that. Times 1/2, because I got to do the chain of this, right? Now, which means I need a 1/2 inside. What do I counter that with outside? No, that's okay. I was just thinking, some people, well, I'm going to stay with the way I'm. All right, so I have 2 times the integral of u squared du now. No, because all of this together makes up the du. So now add 1, which will be 3. So I got 1/3 u cubed. Right? So 2/3 u cubed plus c. U was 1 minus cosine t over 2. This looked worse than it was. So antiderivative here. add 1, and then take that and divide. I hope these are getting a little better. Don't forget the D. Definitely don't forget the C. Oh, y'all are haters. That's the final answer. I still say the hardest part is figuring out what your U is going to be. So I look for what I already have a derivative of in there also. I look for the two functions and I look for what I have the derivative of. I know that tangent and secant squared are related, right? So which one is the derivative of the other? Right. So I think I'll let U be a tan so that whenever I take the derivative, I've got secant squared x. Yeah. Well, that's already there. So I end up with the integral of the square root of u, which is really just u to the 1/2, right? So add 1, divide. So I get 3 over 2, no, 2 over 3 u to the 3 over 2 plus 2. And then I plug back in. What was it? I was going to be in the middle of an AP exam because I'm not. I'll tell Miss Chickering. Just periodically go. I'm just picking. What else? That's it? Okay. For number 1.
I thought we were doing
We are, but I want to walk you through a couple things that you need to know before I get you started. Yes. If I try to set this up with use, this is how we have to start reasoning too. Everything does not lend itself to use substitution. But there are things that I need to do. Like if I were going through this one, okay, and I said I need to find the integral. Your first thought might be to set up a u substitution, right? What might you use for u? All right, so try them. If I use, don't write this one. Neither of them work. They're not going to work. So if you tried x minus 2, you'd find out your du was just dx. I'm still stuck with this 4x squared, right? If I tried to make it 4x squared, my du would be 8x. And there's no way to force this to be 8x on the bottom because I got this aggravating 2 down here, right? Are y'all following what I'm saying? So I'm in a bit of a conundrum. So here's what I can do. Because I'm top heavy, right? Everybody sees I'm top heavy? Y'all okay there? I'm going to do division. I'm going to do a long division on it. So, and in this case, I wouldn't have to do long division because it's just x minus a number. Remember, that can be done synthetic. But whichever way you remember, it doesn't matter. I'll do it both ways just to jog your brain. X goes into 4x squared. 4x times, I multiply around, and I subtract, I end up with 8x. Do it again, x times what gives you 8x? Where do you say 8? 8x minus 16, and so I end up with this remainder of 16, right? 16 over x. Okay.
You run that through.
Okay, sorry. All right, so I look at the first, And I say, what can I multiply this by to get this first term here? 4x. I put that in the x column. And then just like regular long division, I multiply around. Yeah, like if you had...
you subtract it. So
you can't do it for everyone, but if it's a top-heavy one, you can.
minus
Okay, so after you put up, right, I got 2. I multiply 2 times 2 is 4, and then you subtract, right? So you did 4x times x is 4x squared. 4x times negative 2 is negative 8x, and then you subtract all of that.
you get negative 8x.
You subtract it, so 0x minus negative 8x gives you... So what's on top, this goes inside,
What?
this goes outside.
So you get 8x plus.
Yes. You have to have placeholders if they're not there. So you start with your biggest exponent, and then you have everyone down to the constant.
So 8x minus 14.
So then I start that process all over again. What do I multiply x by to get 8x? 8, and then I multiply around. Coming back to you? I told y'all, it's always the algebra. Synthetically, what this would look like, remember, this is only when it's x plus a number or x minus a number. In the case of this, it is. So you put opposite sign with that number outside and an upside down division. And then I need the coefficients of what would go in here. So 4, 0, 0.
So I remember this.
Yes. It just doesn't always work. In this case, it does, but it won't always work. Drop the first one. Multiply them together and add. Multiply and add. This is remainder, constant, x. If I had another column, it'd be x squared, x cubed, and so on and so forth. I end up with the same thing, 4x plus 8 plus 16 over what I divided by. Okay, this doesn't give me the answer to the integral, but it allows me to evaluate the integral a little easier, because now, instead of having this integral that I can't do u sub on, I can have this integral that looks like this, 4x plus 8 plus 16 over x minus 2. I'm just writing it a different way, and because I can split my integrals up, you'll probably have 1 or 2 multiple choice questions on this. It's never... But they literally put this in our standards. Integrate functions using long division and completing the square. So guaranteed it's going to be at least 1 multiple choice question. Now this becomes an easy integration problem, yes? Antiderivative of 4x is 2x squared. Antiderivative of 8, 8x. This is the one that's going to be a little bit harder, because this one I am going to have to do a little bit of a u sub if you can't see it. Right? Yes, I would make u x minus 2, which means du is just 1 dx. And I can take this 16 and put it on the outside since it's a constant. So I have 16 times the integral of u to the negative 1 du. What's the antiderivative of u to the negative 1? ln. That's exactly right. Anytime you have negative 1 in here, it's always the natural log of the absolute value of. That part's confusing. So look at your pink sheet. So I let x minus 2 be u. So this becomes the integral of 16 over u du, right? Because I'm multiplying this 16, it's like a coefficient in front, right? I can take that out. Because it allowed me to replace the dx with du. Because before you can integrate, your variables have to match. Do what? That's on your pink sheet. That's just one that you have to remember. The antiderivative of 1 over u, or the antiderivative of u to the negative 1, is always natural log. Yes, this is the final. You do like that? They do. You just always put the absolute value on there because logs can't be negative. That's just part of the formula. Now, the other thing I need to show you, you're not going to like this much. Huh? No, there's another problem. Look at number 4. Okay, so how would that work? Okay, so if I put the 8 in the front, I end up with 1 over x squared minus 10x plus 26. We haven't talked. No, this. There's little pages at the bottom. It's okay. Okay. Sorry. All right. Okay, factor. What multiplies to 26 and adds to negative 10? Nothing. Nothing. Oh. I am. That is. But you heard me say we have to do it with long division and completing the square. But here, I want you to see why. Because for me, the hardest part is determining what I need to do. Is this a U sub problem? Can I do long division on it? Am I going to have to complete the square? What's fine? 9 times out of 10, U sub is going to work. But then you got that 1 out of 10 times where you're going to have to decide, should I divide it long division and split it up, or what else can I do? This one, long division's out on this one. Why? It's not top heavy. That's exactly right. So I can't split it up. You see why? If I tried to do long division on this, I'm not going to get anywhere with it. That is the remainder of some division problems. So here's what I'm going to try to do. I'm going to try to complete the square, because by completing the square, I'm going to have something squared plus something. So we got to go back and remember how to complete the square. Okay, all right. So let me just, this is going to take just a minute as I refresh you, okay? So y'all bear with me. All these problems do not take this long, but I need to go back to Algebra 2, and then I need to go back to pre-cal on how we did it a little bit more efficiently. All right. First thing back to Algebra 2 is perfect square trinomial, right? That's where both ends are perfect squares, and in the middle, it's double the product of the square roots of the ends. Remember we said square, square, multiply, and double. Remember when we did that? Please tell me you did, because I'm an idiot dancing around saying, okay. So this factors as the square root of the first, whatever this first sign is, the square root of the last squared. That's what's nice about a perfect square trinomial, right? Okay, for example, y'all are looking. That is a perfect square trinomial, yes? Second sign's a plus. The ends are perfect squares. If I take the square roots of both ends, I get x and 6. If I multiply those together and double them, I get what sits in the middle. And that is nice for me because I can factor it like this. If I can get it factored like that, I might stand a chance for a U sub or something else, okay? Possibly, but we'll see. We'll see what happens. Now, it may not start out looking like that, and we might have to find a good C. Remember when we did the good C? Okay, so maybe I have x squared plus 8x plus 15. And I said, make that a perfect square trinomial. That number needs to be 16 instead of 15, right? So I come here and I go, I'm going to ignore that one for just a minute, and I'm going to do plus 16. But this plus 15 is still here, right? To counter this plus 16, because I can't change the value of anything, I'm going to also subtract 16 at the same time. So I add and subtract it at the same time. Now this gets hard when we have a leading coefficient. Okay, so this is the plus 15, right? It's not in this problem. I'm doing a separate example. I'm just walking you through. We're going to just hold it to the side for a minute. We're going to combine them and hold it to the side, yes. We were solving. In Algebra 2, we use this technique to solve. In Pre-Cal, we use this technique to change into like a vertex form of a quadratic. We didn't use it so much for solving and more for quadratic form. Now we're going to use it as we evaluate integrals to rewrite things. So watch what happens here. This becomes x plus 4 squared, right? But I've still got these two things, which gives me a minus 1. And it stays like that. It's going to help me in U sub over here. Now, be very careful, because had this had a leading coefficient, let's say it was 3x squared minus yes. So I would factor that out, right? You're going to have to. Even if you have to make it a fraction, you have to factor it out. I've not seen any quite this difficult, but I'm going to do this as a plus 4 here so you see what's happening. But really, this is a plus 12, right? All right, so I have 3x squared. What's my good C that I would need? 16. Oh, it's the same good C. Well, it's got to be half of the middle squared. Can you do what? No, the last one has to be positive. As long as the second sign is plus, the first sign doesn't matter. Now, I set this up kind of funky because I wanted you to see what's going on here, because no one ever really understands. This is a minus, what, 12? But it's not really minus 12. It's minus 36. So, yes. So I'm going to keep this 3 out here and do this, but I'm going to put the minus 36 outside because I want to factor this. That was the whole point. And so now this is 3 times x minus 4 squared. Again, I haven't seen any that hard for completing the square, but just in case. I kept the 3 because it's still being multiplied to these, but I wanted to get rid of this one. I wanted to put it outside so that I could factor this. It's the square root of the first and the first sign and the square root of the last. always the algebra. It's always the algebra. Okay, so let's look back at this one. I've got to determine what I need to do, right? Yeah. Okay. I'll give you another one. That's fine. Okay. All right, so as I look at this, I have to determine which direction I'm going. So obviously with antiderivatives, can I take the antiderivative as it sits? No, right? I can't take the antiderivative. Number two, can I do maybe a long division setup or no, I can't do a long division setup. I can't split it up because there's no way. I got to complete the square and see if that will help me. Okay, so complete the square on this one and tell me what you get. Marks that guy. Just complete the square there on the bottom. Yes. I wouldn't do the whole bottom because if you do that, you'd end up with 2 times x minus 5. See what I'm saying? So I would just let you be x minus 5. It is a rule. Most of the complete the square ones are going to give you a function. I end up with 8 times the integral of 1 over u squared plus 1 e. You're back to the same question you asked before. Do you understand? Do you see what it did? Okay. Well, what's the derivative of x minus 5? What is this? What's the antiderivative of this? Inverse tan, right. That's on your pink sheet. They do expect you to. I will tell you when we get closer to ones. Like, I would make sure I knew inverse tan. You talking about the inverse functions? I would say inverse sine and inverse tan are the two that come up the most. I don't know that I've ever seen inverse secant or inverse cosecant as one-to-one. Not now. Don't forget the C. How is it what? Because I meant. Maybe to start with, because yeah, it is. But we'll get to there now. Tell me what you think. Think you can try a few? All right, let me tell you what